Pushkin. About a decade ago, special cameras in the rafters of NBA arenas started following all the players around the court and tracking the ball everywhere it went. It was this huge new trove of data, but nobody really knew what to do with it. This is a very familiar problem in the modern world. Tons of data that just kind of sits there. Then a few computer scientists came along and had an idea for how to solve the problem. They thought they knew how to take all that data and turn it into profoundly useful information. And so they started a company called Second Spectrum to see if their idea would work. I'm Jacob Goldstein, and this is What's Your Problem?, the show where entrepreneurs and engineers talk about how they're going to change the world once they solve a few problems. My guest today is Rajiv Maheswaran. He's the co-founder and president of Second Spectrum. The company started out turning video of NBA games into information that coaches could use. Today, they work with every NBA team and with Major League Soccer teams in the US and with Premier League teams in the UK. Rajiv's problem is this: how do you teach a computer to understand sports? Rajiv and his co-founders started Second Spectrum back in 2013. Last year, the company was acquired by a sports analytics company called Genius for $200 million. My conversation with Rajiv focused on his work with the NBA. That's where Second Spectrum has been working the longest. But he started out talking about this bigger idea. How do you turn data, really any kind of data, into something useful?
So I think this happens everywhere. There's a lot of companies that collect data, faster data, more data. But what generally happens is the big piles of data, I feel like they're like grain. They just, if people don't know what to do with them, so they just stick them in the closet. And it's like, yep, I got piles of grain in there, and it keeps piling up. And I think what we said was, we brought a bunch of machine learning, a bunch of other stuff to it and said, the data, this massive amount of coordinate information, no one can work with it. Coaches can't work with it. The leagues have a tough time working with it. The media has a tough time working with it. We are going to sort of grind that grain into story elements that people can actually use. So we turn it into, that's a pass, or that's a shot, or that's a pick and roll, or that's a between the lines pass, or that's a blitz. And so we start turning them into words by which people can tell stories. So I would say, like, the grain is not useful. You want to make like bread and donuts.
Is there some particular example you can give me from the early days of the company of basically of a problem you solved, of a thing you set out to do? Maybe it was hard to do, maybe it didn't work the way you thought it would, but in the end, you made some useful thing for coaches, teams, whatever.
There were two things that we did that sort of were a big game changer, right? So one was the idea that people were taking shots and you couldn't tell if they were a good shot or a bad shot. You would use some rules. It's like, if you took it here, if people weren't guarding you too closely, it was good. But, if you dribbled a lot and you jumped in somebody's face, it was bad. I think we were able to use math and say, that shot should go in 42% of the time. That shot goes in 49% of the time for an average player. It goes in for this player. So we were able to quantify the quality of a shot, which was basically the core thing in basketball. Is you want to get high quality shots and prevent high quality shots. And there was no way of measuring it. And we basically said, like, no, we know exactly what the quality of the shot is. And then we also know which players add value beyond that shot. So players like Steph Curry and Kevin Durant can take a shot that might be a 45 for an average player, and for them it goes in 55. And that was a big deal. That was the first big thing.
Just to step through that a little bit more slowly. So before you came along, what did people know? What did coaches know about sort of percentage probabilities that a shot would go in?
They would just track it much more coarsely. So they would say, from the corner three, or you would shoot this, and from above the break, you would shoot this, or in the lane, you would shoot this. But they didn't know things like, hey, there's a really tall defender running straight at you, or you're moving sideways. And these things also matter.
Very important, yeah.
And then the raw data allowed us to know all that. And then what we did was start to build models that basically predicted the likelihood of various shots going in.
So one of the things you did is coming up with a better metric for shot quality that has more inputs. The other thing you did, is it right, was around the pick and roll?
So I think there are all these events in basketball, and you can get pretty esoteric. There's pick and roll, but there's many types of pick and rolls. There's many types of ways to defend pick and rolls.
And just to be clear, let me just say, we won't go into detail, but pick and roll it's just a play. It's an offensive play.
It's a play, yeah.
It's somewhat complicated. It involves 2 people on offense and 2 people on defense. Let's just say that. It's a
That's
common
all you
play.
need to know.
Okay. So what did you do with the pick and roll?
So I think the first thing that we did was we had a machine be able to identify it by staring at the data. So before us, it was basically humans would watch the video and just start counting how many happened and counting what the type of defense was. And basically they would just collate all that information. But I think the big thing that we discovered is when machines did it, the big example was there was a year where the human collection said Chris Paul led the league running 800 pick and rolls. And we said, well, Chris Paul led the league running 4,000 pick and rolls. And one of these is not right. But then we could just say like, well, here's our 4,000. And then you're saying, oh, okay, you're missing sort of, 80% of them. And so I think once we did that, we could automate a lot more complicated things like having the machine understand all the defenses that you could play against various types of pick and rolls. And then once we solved those, we sort of built this engine that could generate words accurately. And then we started growing teams and each one of them would say, hey, can you do these words? Can you do these words? Can you do these words?
And like say some of the words they were asking for.
So there's sort of like, flares and loops and zippers and jams and trails and whips and, veer backs. And I mean, these
and these things are basically what plays, their defenses, their moves.
That's right. So there's like sort of, the particular kind of screen that they use to get Steph Curry free off in the side versus the name of a defense that the person running after him might choose to play while he's doing that thing, right? So
to avoid that screen. Yeah. And when they say learn a word, they really mean, can you teach your machine or get your machine to learn to recognize this play, this thing?
Because they want to know every time they do this, 2 questions. Every time they do this and we do this, how efficient is it? And or every time they do this and we do this, show me every time that a video of every time that happened over the last several years. Those are the questions they tend to ask.
Okay.
And so it has a bunch of quirks, working with it, but it was not easy, but we've done it. And now we've created sort of 500 of these words that, coaches and, players use on a daily basis.
Okay. And so I can think of 2 parts of this that would have been sort of hard problems to solve. One being the kind of mathy computer part, like building the machine. Yep. And the other part being the getting people to believe you and use your insights.
Oh my gosh, yes.
So tell me a hard thing, from each, right? So what's a hard thing from the mathy computer part?
I think the math side is just that you don't have a lot of data. So it's, for example, a lot of people who do machine learning will say like, oh, give me millions of examples of a thing and I will learn it. Well, there aren't millions of pick and rolls that you're going to get to sort of.
So how do you solve that? Right. Small sample size, classic problem.
Small sample size. So,
how do you solve it?
Well, there's some mathematical chicanery that we invented.
But the answer is be very clever. Like we're really good at math. Is that the unsatisfying answer?
Yeah.
Let me ask you this. Was there some like things you tried that didn't work? It was just like one equation didn't work and then another did? I mean,
Yeah. No, I think we said over the course of our life, we've used everything in the AI textbooks to try and solve the problem, and they've evolved over years to try to get to be better. But I think that that's part of the adventure of sort of trying to figure that stuff out. It wasn't like we used method X and the answer popped out, and so we've been constantly evolving the ability to do. But I think part of whatever the secret is, you have to leverage the structure of the problem. You have to leverage the fact that you know something about the fact that it's a bunch of people playing a particular sport. When you don't have enough data, you have to leverage structure in some way. Yeah.
So you're able to, because it's such a constrained environment, because you know the rules, because you know the things you want it to find, you can sort of say, this is a pick and roll, this is a pick and roll, this is a pick and roll, this is not a pick and roll, this is not a pick and roll, that kind of thing.
Yeah.
Good. So that's the math sort of technical side. Then there's the getting people to believe you and, buy what you're selling ultimately, both metaphorically and literally. Tell me about that side. Like, were there any interesting, I don't know, people who didn't want to buy it, little stories from that side?
Almost every coach that we've talked to couldn't believe that we did what we believed. So the stories generally involve just sitting there in front of these coaches. You go up a couple of levels. So I think that, this happened with two coaches. It's a very similar story. They were very well-known coaches, long resumes, have been around the NBA for a long time, won lots of championships. It took several meetings to even get an audience with them. You would go through sort of layer one, then layer two, then layer three, and then you would get to them.
It's like meeting the Pope or something.
Exactly. And then you would sort of get to them, and they would just basically say, like, you have no idea what I intend for the players to do. There's no way this machine can understand what you need. And we would say, try us. And we would say, okay, show me all the times that the play started with a pick and roll and there was 3 passes and I took a shot in the corner. It's like, okay, here it is. Like, show me all the times there was an off-ball screen. When you're saying
show me, you mean like you have a laptop and you have your software running or something?
Yep, that's right. And we would have tables and charts, and we would project onto a screen, and they would basically just give us the quiz, the sort of the they would put us through the ringer for like 2 hours. So it's basically a impromptu grilling from the coach, and make your machine dance for me and show me the correct answers. And anytime you come up with an answer that I don't agree with, I'm going to think you're an idiot. But we held up. In fact, sometimes these coaches would say, wait, show me this list. And if these 2 guys aren't number 1 and number 2, I think your thing is wrong. And then we would do it. And like, thank goodness the right players would end up number 1 and number 2. And then normally after sort of 2 hours of grilling, they would be, pretty good. And they would just leave the room. And then we knew we would have a contract.
And is the output like the thing that actually you see on the screen when you're running your software? Is it lists? Is it little videos where all the players are dots? Is it both of those things?
It's everything. So we have sort of rankings tables that can answer who's the best at X, Y, and Z. We have sort of a variety of visualizations that show breakdowns of various actions. You can always click on anything and show all the video of every moment, anything that you asked it. So we've built lots of visualizations and data formats to make it easy for various people in the organizations to use them.
There are instances in the world in different domains where like a data-driven approach suggests doing one thing, but that thing is contrary to conventional wisdom, right? But like in football, it seems pretty clear that the data suggests coaches should go for it on 4th down more often than they do. And it seems like as a result, coaches have started going for it more on 4th down. But there is this thing where if a coach goes for it on 4th down and doesn't make it, the team doesn't get the 1st down, then the coach gets pilloried, right? So even though the data says it makes sense to go for it, in a kind of a personal incentives way, it might not make sense, right? In a social way, which is real and important, it might not make sense. Is there a basketball version of that? Is there a version of that you have observed where your data suggests that coaches should be doing something, but they're reluctant to do it because it's contrary to sort of conventional wisdom?
No, I think there's a lot more nuance in what we do. I think the public basically is aware that they say, oh, people should take more threes. But I think the reality is much more complex than that, because I think it's not about just simply take a 3. What you want to do is get the best possible shot for yourself. Sometimes that's a 3, sometimes that's something else. Different kinds of threes are not the same, and your talent is not the same. In fact, if you look at all you list sort of LeBron James and Kevin Durant and Steph Curry and Giannis and Jokic and all these players, and they are very different players, and teams are built around these players. And what you want to do is optimize the team built around these very unique players. And so a lot of it is in the details of how you structure your offense and your defense to sort of use them to get your team the best possible shot. So a lot of it is these coaches do a lot of work on the micro level to sort of create these plays that it's not just sort of walk up the court and take a 3. Yeah. They do a lot of work to try and put their their players in positions to have a lot of good options to get the best possible shot. So I think that it's really a lot more nuanced in the actual execution of it. Fans would be really surprised at the level of sophistication entirely across the league and many leagues in sports, especially the top ones. There's a degree of sophistication in how they use data and video that I think would surprise almost everyone.
You think that the sort of play calling side of coaching will become more and more delegated to the machine? I mean, I could see coaches as essentially psychologists being persistently useful, but do you see a time when the sort of core strategic decision making will just be done better by a machine than by a coach?
I don't think so. Our thesis has always been we build Iron Man suits, and different
Uh-huh.
people will want different Iron Man suits, and you will want because you need somebody in the middle of the Iron Man suit directing it, using everything they know about the world. But you want to be a lot more powerful, and I think that's the model we've always used is we build Iron Man suits for everybody, and then different coaches and different assistant coaches are going to use them, to be a lot more powerful. That's what we want to do. We want to build Iron Man suits for everybody.
Does basketball look different? Is it played differently because of your work?
I certainly know that there have been examples where, in a couple of NBA finals, strategies were changed because of the data that we provided, close ones, or where one team basically discovered a pick and roll defense strategy that was effective and employed that, and it to, very good effect. Another one, it was one of these sort of off ball screen defense strategies where they found the data showed that there were particular strategies that would shave off a couple of points of efficiency from the other team. And they employed that very heavily and they won a very close series. So I think.
Can you say what teams it was?
I should not.
Okay.
But I think if people look it up, they can probably figure it out. The point that I want to realize, like, there are a lot of people who come out and think like, oh, these teams are sort of the geniuses and these teams are the Luddites. And that's not the case. Like almost every team is like, people would be surprised at the minimum.
Well, that's fine. I mean, everybody in the NBA every player in the NBA is good at playing basketball, but some are better than others. And so similarly, you might imagine that every sort of quant team in the NBA is good at being, doing quantitative analysis, but some are probably better than others.
So I would say you're right. There are some who are better than others, but the minimum level is a lot higher than what everyone would.
Sure.
Yeah.
And can you say who's better than others?
I cannot. This is our lifeblood of being. The reason that all these coaches trust us and is that we don't leak. So I'm sorry. It would be fun. One day I'll tell all the stories. It's not today. I'm sorry.
Rajiv is not going to name names today, alas. But he is going to talk about a big, interesting problem that Second Spectrum is close to solving, but has not quite nailed yet. That's in a minute. Now, back to the show. I want to talk about things you haven't figured out yet. Like, what are the next problems you're trying to solve? Like, what is the frontier?
So I think the frontier, where we're trying to basically get full body pose of the human, not just a little dot. We're trying to get their entire skeleton.
So the basic sort of product you have, the basic thing you do, turns each player into a dot, just like in the classic like X's and O's diagram or whatever. And so you can watch little dots moving around and you can see how far the dots are from the other. But there's a lot going on that you don't see in the dot, right?
That's right.
You might want to know, like, what are the things that are important that you don't see in the dot?
That's exactly right. So the challenge we're working on right now is turning the dot into a human skeleton and then having that skeleton generate data in 100 to 200 milliseconds. So that's the challenge that we're working on right now. And we've actually made a lot of progress on that. And that's right now.
And so what's an example of why that would be useful? What are some of the ways you could learn from seeing each player as a whole body rather than as a dot?
So I think there are a lot of things you can do. There's one is obviously, with health and fitness, where you can figure out, like, did they land on 1 foot? Did they land on 2 feet? Did they take off from this foot or that foot? So there's a lot of health and fitness stuff that you can figure out.
Health and fitness meaning learning to reduce the risk of injury, learning that certain kinds of moves or subtle distinctions in moves make a player more or less likely to be injured?
That's right. And so that's one class of things we can do. Another class is sort of just understanding moves better. So if a player made, dribble moves between their legs and crossovers and step backs and did all kinds of things with their hands and feet to get open, now we can categorize those things. There's that, there's health, there's strategy, there's media, there's officiating, you can help with officiating if you start knowing where people are. So there's a lot of things that you can do once you understand more of the human skeleton.
And let me ask you this, why is that hard? I mean, it sounds hard, but tell me about that being hard.
So basically, you have a bunch of cameras in a stadium, and it sees these sort of blotches of that you tell them it's a human, and you have to say like, oh, that's a knee, and that's an ankle, and that's a waist, and so it's just sort of you're teaching a machine to see a human from scratch. And it's not that it's there's been a lot of progress in computer vision over the years that is making this problem easier and easier. A lot of it is also just doing it extremely quickly. Like you want this machine to be able to do it on the order of 100 to 200 milliseconds to be able to enable a lot of things to happen in real time in sports.
100 to 200 milliseconds.
But you might want it to be only delayed from reality by a tenth of a second.
Let me ask a dumb question. Why can't you just let it take its time to figure it out? You're not trying to do it in the middle of the game, right? Or are you trying to do it in the middle of the game?
Because I think sports is one of these interesting, this is part of the reason why machines' understanding of sports is so hard. In sports, it's not like you want to analyze a video and then know what happened a long time later. That might be the case for coaches. But for a lot of media applications or refereeing applications, you want to be able to do it basically instantaneously.
Yeah, right.
And so it's almost like the self-driving car. Like you need it to be able to do its thing very, very quickly to be able to react to it.
Is self-driving car research helpful to you? Are you borrowing from that?
Well, yes, because I think that's generally pushing the field of computer vision forward, because it's basically the same problem. You need to identify people and what they're doing very, very quickly. So one is to sort of avoid running into them. The other one is to sort of figuring out what's going on a sporting event. And so I think the general trend of computer vision research moving to solve these problems quickly is helpful.
Have you figured out anything yet about injury? Like, do you have any useful injury insights?
I mean, I've always been, to be honest, wary of injury because it's a hard thing to do. But I think that what we have
wary of studying it, wary of trying to build predictive models. I've always been wary,
but to be honest, the teams use the data we give them in that way, even though I don't want it to happen, because they just it's any information is better than no information. And so I've always been, the whole 9 years I've said we'll give you the information, but I'd be careful. But it's such an important thing about keeping athletes.
Why are you so wary of trying to figure out injury risk?
I don't know that at this point. I think that I've seen stuff that is super predictive, that the scientists that I would sort of lay down on. I mean, I know there are a bunch of other companies who have.
So because it's such a hard problem, because you don't feel like you can reliably predict it yet.
Yeah.
What is it about injury risk that makes it so much harder to understand than sort of things, that are more kind of within the game itself?
I mean, I just think that, it's almost a sample size thing. People get injured in all sorts of, unique ways, not super often, right?
Yeah.
And so, I said there aren't that many pick and rolls, but there are way more pick and rolls than there are, whatever, ACL tears or whatever those.
Yeah. And presumably injury is more complex.
Yeah,
it's a more complex problem, and it happens way less often.
That's right.
Which makes it harder on both sides.
That's right.
I want to talk a little bit about the applications or potential applications of your work beyond basketball, the extensions of your work beyond sports. I mean, sports and games more generally seem interesting as a sort of testing ground. Obviously, they're useful in and of themselves, but also as a testing ground for AI in particular, right? I mean, if you think of chess famously and then Go, you had DeepMind figure out chess and then Go, and then they solved the protein folding problem, this profound problem in biochemistry, basically, right? Tell me about that. I mean, well, why are games and sports a good place to start?
Yeah, so I think that I think one of the things that we're doing in sports is the general problem of human activity recognition, right? So that's really what we're doing. But people do a bunch of stuff in a space, and we want to figure out what they're doing. And we didn't actually put sports in the name of the company because we thought we might go beyond sports, but it turned out there was so much stuff to do in sports. We sort of stayed here. Sports is interesting because it has the ability to create a lot of data capture, and the activities are sort of bounded and well known. So you can just have this this intense capture of this various rectangles based on sports, and then it's very clear what some of the activity recognition is. And so it's a great place to sort of start with human activity recognition.
So what is the obvious adjacent thing in the world where what you do might be useful?
I think that if you look around the world. This can be applied everywhere. So, for example, in your house, right? If you have cameras in your house and you've been able to figure it out, like, oh, someone has fell down, or the kids are fighting, right?
In my house, it feels a little creepy to me. Like, I don't particularly want it in my house, I will say.
That's fine.
Yeah, I'm not necessarily against it, but like, it doesn't feel creepy at all in the NBA to me.
No, that's why I like working in the NBA. Yeah. So a lot of the other things are sort of, I've seen there are other companies that basically watch how people move around stores. So you can say, oh, this is where we should put food, or this is where people are congregating, or this is where we get blockages, or this is the travel patterns inside a store. So I know a bunch of companies doing that. So I know that sort of security and stores, there's a bunch of companies out there. We were approached by people who were like to go to concert venues and say, okay, can you put a bunch of cameras and figure out how people move in and out of concerts and figure out
where the bottlenecks,
exactly.
How does the foot traffic flow?
So we've been approached by lots of different industries to say, can you apply what you're doing to us?
And what have you said when those people have approached you?
I always said, I would like to get to it, but I think that the sports has kept us so busy over the years that we've just had plenty of work to do in sports.
In a minute, the lightning round, with lots of questions about basketball and a little bit about soccer. That's the end of the ads. Now we're going back to the show. Let's do a lightning round.
Lightning round.
Who's your favorite NBA player of all time?
Larry Bird.
What does the data say about Larry Bird as a player?
He was very good.
Fair enough. That lines up. So it seems like still, at least to some extent, there is this cultural divide in the NBA and in other sports between the data people and the sort of old school sports people. And I'm curious, what do the data people not get about the sort of traditional sports people?
I think that what happened was, the traditional sports people spoke in words and the data people spoke in numbers. And I think that that's what needed to bridge. Like, basically both people had to speak words and numbers. And I think that's happened.
So you think that divide is done now? It no longer exists?
Yeah.
Is it still fun for you to watch basketball, or does it just feel like work?
Oh, no, it's fun. It's fun.
According to the data, who is the greatest basketball player of all time?
We're unable to do that because the data capture only goes back 5 years.
Who's the greatest player of the last 5 years?
The last 5 years? Steph Curry.
Who's the greatest soccer player of the last 5 years?
Messi.
Can you compare Steph Curry and Messi in some quantitative way?
Yeah, I think that all the great players have some number where they perform something far above expectation.
I mean, is it a dumb question to say who's better, Steph Curry or Messi?
It's not, but it's not a question that coaches tend to worry about.
Well, sure, but if it's not a dumb question, I'm going to ask you, who's better, Steph Curry or Messi?
The reason is that we haven't built so it's almost every question requires building a set of tools to answer them. We could, but no one has asked to build those tools, because I think what you would want to do is say,
you could answer that question, but I'd have to pay you to do it.
Basically, because I think there is a way to say it, because how much of basically the question you're asking is, how much was an outlier was this particular person compared to everyone?
Yeah, how much value did he add would be a clumsy way to say it.
Yeah, and I think that there are definitely ways to answer that. That's sort of that is not where we have spent our time, but I don't think it's unanswerable. I think that there are interesting ways you can go about answering that question.
This one goes to sort of data versus kind of public acclaim. Among NBA players, like based on the data versus what people think in general, who's the most underrated player right now?
Say Chris Paul. I mean, he's not really underrated, but he's not quite at the pantheon.
You can be highly rated, but still underrated.
That's
underrated
right.
Does not mean low rated. It means not rated high enough.
That's right.
Who do you think's the most overrated player?
Oh, that's a good question. It's tough. I'm saying no one just jumps to mind, because I think
well, also you could get in trouble, right? You're gonna call out one of your clients' stars.
Well, there's two questions. One is like, hey, I thought of someone, but I don't know who to say. I don't want to say it. But right now, I can't actually think it, because it's a lot of people. People are much better at rating nowadays. I think that's a lot of what has changed over the years, is that because there's so many more numbers, like the error bar in ratings have gotten a lot narrower. So players have gotten more appropriately rated, because fans are savvier about the exactly.
data.
So what has happened in the is big centers are not as valuable in basketball, but you actually see that, like, they're not rated as highly, you know, and so a lot of a lot of big centers who would have had, you know, massive contracts 10 plus years ago aren't getting those now, but that's because, you know, the ratings have adapted to value them less.
The data shows that big centers aren't as valuable as people thought.
That's right.
You think you're going to work at Second Spectrum for forever, for as long as you're working?
It's our baby. It's been the baby of many, many people.
I mean, babies grow up.
I think that there are problems I want to solve. And sure, I would love to be able to solve all those problems. And then then I'll say, what will I do next? But I think there's certainly plenty of problems to be solved.
Rajiv Maheswaran is the co-founder and president of Second Spectrum. Today's show was produced by Edith Rousselot, engineered by Amanda K. Wong, and edited by Robert Smith. I'm Jacob Goldstein, and we'll be back next week with another episode of What's Your Problem?